Cisco Certified Network Associate Day 26. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about DNS and DHCP. And DNS and DHCP are very critical in your networking world, especially for internet, to setting up internet and browsing the internet and things like that, right? That is where DNS comes in. And DHCP is something we have already discussed, but we're gonna look at how to configure DHCP servers, right? So without wasting much time, let's get straight into today's class. Like always, before we go ahead, these are social media hubs, so please feel free to connect with us in different mediums, and of course don't forget to give us a review on Facebook. We have our Facebook page at NetworKing Consultant, so please give us a review there. We would really be happy to get reviews and your feedback there. And of course subscribe to us on YouTube, and that's what makes us give you all these free videos, right? Today we're going to look at three things. We look at how the DNS works. We will configure DNS, and we'll troubleshoot and see what are the troubleshooting that could happen using DNS. And of course we will configure DHCP and troubleshoot DHCP, right? Before we move ahead today, we will look at something which is definitely not part of our CCNA, but I want to give you a basic idea of how we host a new website, right? So let's say any of you are interested to develop websites, to learn about HTML, CSS, PHP, JavaScript, the whole web development thing. I am definitely going to start a new series. I have a lot of requests for starting a web development series, so that's something I'm going to start. Honestly, time wise, I'm not very sure how much time I have, especially considering this is not my full-time job, right? So I am going to definitely start another series with web development whenever that is, but I'm just going to give you a snapshot how websites are developed, not exactly development, but more of hosting and the networking side of a website. So what happens is you go to a domain name register, like for instance GoDaddy, right? This video has nothing to do with GoDaddy. GoDaddy is just an example. There are so many hosts that you can go to. Anyway, you go to this website, search for your domain name, let's say imran.com, and if that's available, or whatever, imran.org, imran.net, imran.in, whatever, right? What is available, you go there, look at it. If you like the price to be paid, it could be like $10, $8, $7. It all depends on the domain that you are looking to register, and which registrar you're registering from, right? So sometimes you have offers, 10% off, 20% off. So it could vary from maybe $10 to maybe $2,000, depending on the domain name that you're trying to buy. So you buy that domain name. Once you buy that domain name, the next thing that you need to do is buy a hosting space, right? So domain name is your first step. That's your name on the internet. You buy that. That is how you are going to be recognized on the internet. And what hosting does is, let's say you have a website that you've designed. You've used HTML, CSS, JavaScript, whatnot, whatever that you want to use, you've used, and you have developed a website, a web page, a few web pages strung together, right? So that's your work. You've done that. Now you need to buy this space on the internet, right? You could buy space from, again, GoDaddy or any of the hosting services that's available. You buy some space and you upload your files there, right? That's your second step. The third step is linking these two, linking your domain name to the host, right? So if somebody comes and types imran.com, you need a way to tell that computer, whoever that person who's browsing to imran.com, to tell where they should find the website, the files for the website, the HTML files, right? So that is the step you do in the linking part. So let's say, to summarize, so it's more like, this is your domain name, right? And domain name, you have files. So let's say it's a different host, right? And this host is 74.1.1.10 something, right? And this is where I have the files. So from my computer, or somebody is browsing to this website .imran.com, there should be a mechanism for this computer to know where to find those files. So this computer would send that request to this server, right, where you host the file, and this server where it hosts file will send the file back to your computer, and your computer will display the website. And that is how it is done, right? So this part, the linking between domain name and host, is done. Now the reason why you link the domain name to your hosting server is because you technically could go into this computer, right, and type in your web browser where you type www.imran.com, you could technically type 74.1.1.10 or whatever that IP address of my host is, and it will work. You will get whatever the file that you get from my website, you will get it there. But is it easy for you to remember this number, 74 or whatever that IP address? No, it is not easy. It's very difficult for us to remember this number, and that is why we create a domain name. Now the advantage is, let's say tomorrow I don't like this hosting. This hosting is very expensive for me, right? They've increased the price. I say fine, I don't want you. I want to buy another host somewhere where it is cheaper, right? It's a cheaper host. So I put those same files, upload here, and I link. Instead of doing this link, I cut this. I now link to this. This is my hosting server. So next time somebody goes to www.imran.com, this will redirect to my new server, which is, let's say, 50.1.1.10, whatever, just a random number, and this server will send the reply back to your computer, and your computer will get those same website, right? So technically, for all the users, they just need to remember www.imran.com, and they need to not worry about where I've hosted this file, right? This is the reason why you have a domain name and you have your host, right? This is just to give you a gist. It's not part of your thing, and if you want to learn more about hosting websites and things like that, that's going to be a different series, right? Now let's come to DNS. So what is DNS? DNS, or domain name system, is a system where your domain names are converted to IP, right? So like we said, www or whatever .imran.com, it's something that we all remember. We remember domain names. We are, as humans, we can remember names than we remember numbers. So if somebody types this, there should be a mechanism that converts this to the server, right? The server where I have hosted that file, right? That is the domain name system. So the domain name system will convert the domain name to a host, right? So I'm just going to quickly show you something. This is my command prompt, and I'm going to type ping google.com, right? And it comes up with this IP address. It says pinging google.com at the IP address 82.148.105.31, and pinging is replying. So I can go here and I can type 82.148.105.31, and if you can see, this is automatically resolved to this IP address, and to this domain name, and google.com website is up and running. So technically I could remember this IP address and use it every time. But like I said in my previous slide, that if at all the domain name has to be I need to host it on some other server, that's not going to be possible if somebody is remembering a domain, if somebody is remembering my server IP address, and if I want to change the server IP address tomorrow, there is no way I can tell maybe 10,000 people know about my website at a certain IP address, and tomorrow that IP address changed. I can't go contact this 10,000 people and tell them that my IP address has changed. The best way is they remember the fully qualified domain name, which is nothing but this www.imran.com, and then automatically whatever changes happens behind, so the end user need not know about that change, right? So we can have two types. We can have private DNS servers, right? We can have a private DNS server where we tell our system, we have like let's say we have hundreds of computers, and we want to have a domain name, right? We want to have a local domain name, and we can have a private domain name server where instead of somebody typing let's say your file server in your computer, in your network is 192.168.10.20, right? But you create a private DNS, and people can just say file server, and it automatically resolves that to the 192 server. Again, the same benefit. As an administrator, he can change the file server IP address to anything tomorrow, but automatically, because of the private DNS server, you can you can change it. Also, we could have a public DNS resolver, right, where let's say if you're configure an IP address from your ISP, and ISP gives you a DNS server IP address, that is the public DNS resolver, right? So that means every time your computer, let's say you go to your computer and you type imran.com, for instance, your computer doesn't know what imran.com is or what is the IP address of imran.com. It has to contact your DNS server. DNS server, if you remember, in your IP addresses, when we configure IP addresses, there is a IP address or DNS, primary DNS and secondary DNS information. I'm going to show it to you how it is in Windows systems. On a Windows system, this is how this is where we configure IP addresses, like we've discussed earlier: IP address, subnet mask, default gateway. Also, we have this information using the following DNS server addresses. So we could give a preferred DNS, which is nothing but the primary DNS server, and then we can give an alternate DNS server ID, right? So let's say we give automatically, if it's DHCP obtained, normally it is assigned automatically. Either your router will assign it, or if it is coming from the ISP will assign a DNS server. So basically what this DNS server does is, if at all your computer types imran.com and it doesn't know imran.com, if it is already not in your cache, it would send a request to your primary DNS server. Now, in case your primary DNS server fails, that means it's not accessible, that's when it will go to your second DNS server. It's not that you send a request of primary DNS server and the DNS server does not know about imran.com, it will not automatically go to the secondary DNS server. So if your primary DNS server does not know the answer to your question of what is the IP address for imran.com, it will never go, it will fail, your request will fail, and that's it, it will stop there. But if it is not accessible, your primary DNS server, then it will go to your secondary DNS server and it will again try the query, right? So let me just quickly tell you how this works. So this is your computer, right? And your computer is configured to contact somebody called the resolver, right? So normally, first time when you type imrans.com, this computer will check its own cache, right? If this computer has accessed this website earlier, the IP address is definitely going to be there. If it says, okay, I can't find anything in my cache, it's going to send to the resolver, right? This is called a resolver. Now resolver again is going to look into his cache and say, okay, imran.com, no, I don't know anything about imran.com because I have not actually gone to imran.com earlier, so I don't have a lookup or information about the server for imran.com. So what it does is, the resolver will send a request to somebody called as the root server. Now root server, there are about 13 root servers in the world, strategically placed around the world in different countries, in different places. So that means it's got an anycast IP address. That means it is going to go to, if you're coming in from India, then it is going to go somewhere close to Indian root server, right? Or it's somewhere in that geographical area. If you're from United States, then you are going to your root server is going to be somewhere in the United States area, so it is going to be there. So it's an anycast IP address, or anycast IP address is given to that server, and it will reply. It will say, okay, fine, I don't know what imran.com is. No, I don't know, but I can tell you where you can find information regarding .com, or I can give you a TLD server information for .com. TLD is nothing but top level domain, right? So TLD, top level domain server for .com is accessible at this IP address. So it will give you that IP address for the top TLD server, right? Then the resolver will contact the TLD server. This is the .com TLD, right? So this says, I don't know where .com's where is imran.com, but I know what is the authoritative name server for imran.com, and it would send that here, right? Like I said, this needs to be extended for obvious reasons, and then it sends that request to the authoritative name service, right? Authoritative name service, right? So this is the authoritative name server, and this authoritative name server says, okay, Imran.com is available at 74.1.0.1. It sends that information back to the resolver. The resolver puts that in its cache, and it sends that back to your computer. Your computer then contacts that server. Let's say this is the server, which is 74.1.0.1. It contacts the server, and the server sends the HTML file, and it displays that information. Now you would think this takes a lot of time, but technically this happens, the whole process of contacting the root server, the TLD server, authoritative server, and it starts fetching the files from your host. It is less than maybe 2 seconds or less than 1 second. That's how fast and quick it is. So this is the whole process. Now there is a very common public DNS or public resolver that we use. It's the Google DNS server or Google DNS resolver, which is at 8.8.8.8. Now I use this because it's very fast. It's most of the time it's better than my ISP's resolvers. So I use this 8.8.8, and there is 8.8.4.4. These are Google resolvers. And advantages, Google is a big company, and it does a lot of resolving for different. So most of the time, if you're going to google.com, it doesn't have to, right? The Google resolvers already would have most of the things that you're looking for in its cache, right? So it would come to this step, and you would get the reply back, and it is going to be much more faster. I mean, it's not going to shave much time, but by not going here, it might shave just maybe 0.0001 second. But in your networking life, right, even that 0.001 second of saving, or like 10 millisecond of saving, that adds a lot of time. And I mean, when you say your computer is responding slow to a website, and it is just maybe 1 second slow, but you would say, my god, my computer is slow, right? So in today's world, we have come to expect very high speed and response time from our websites, right? So that's how DNS generally works. Now DHCP, now we have discussed DHCP, if you remember the DORA process. DORA is DHCP discover, DHCP offer, DHCP request, and DHCP acknowledgement, right? If you remember the DORA process from our DHCP configuration, which we did from, I think, many videos ago. So if you don't remember, you can go back, watch that video. So DHCP has those information, where what DHCP server generally does is it takes control of assignment of IP address, and it gives those IP address to clients, right? Now your Cisco servers, Cisco routers can be assigned as DHCP servers. This is the format. So you would go into the global config mode, and you could type IP DHCP pool, and you give a DHCP pool name, whatever that. Then it goes to a subcommand, and in that subcommand you can say network, and you can tell what network are you creating this DHCP pool for. Let's say you say network 192.168.1.0, right? You're giving the network ID, and then you give the subnet mask 255.255.255.0, right? So now it would start assigning IP addresses in that network, that is /24 network, which means there are 256 possible or 254 possible IP addresses that this DHCP pool can assign. Then you would say default router. Default router is nothing but the gateway IP address. So you can tell this is the gateway IP address. So every time you assign an IP address to a client, this information, the gateway information, also goes, so that information gets filled in the client. And you need to also tell what is the DNS server, right? DNS, we spoke about DNS now. So what is a DNS server? So it would say, okay, DNS is 8.8.8. I want to set the Google resolver as the DNS server. So DHCP, every time it assigns an IP address, it would assign this as the DNS server to those clients. That's how it works. Now, what we'll do, again, okay, there are a few things. There's one more thing that I want to tell is, let's say in your network, this is the router, and you have a file server, right? And you have a web server, right? And these are already, let's say we are talking about 192 192.168.1.0 network, and this is assigned dot 2, this is assigned dot 1, this is assigned dot 3, right? And you don't, if a new client comes and it requests for an IP address, right, to the DHCP server, and let's say this is the DHCP server, you don't want them to get IP addresses 2 and 3, because 2 and 3 is already configured. So there is a process where you can actually restrict, or you can tell what are the IP addresses that you can assign, right? So what we'll do is we'll take a practical example, and then we will see how you can restrict those information, so that these you can tell a range from which this DHCP pool always assigns an IP address to clients that's coming in, right? Let's do this. Let me take a packet tracer, and we will explain the process in packet tracer. All right, so we have this network, right? I'm gonna just so I'm gonna explain this network. So I have a router. We will make this DHCP, this the DHCP server. So this router would be a DHCP server, and this whole network is the 192.168.1.0 network. I have a web server at 1.3. I have a DNS server at 1.2. right? And then I have two clients. So this client, when I configure this to be a DHCP auto configuration, I say, you know, dynamic host configuration, I click on that instead of doing static IP address. It should pull an IP address from this pool. So I need to set a pool here which would assign this IP addresses here. That's first one. Now, and I will also go to this DNS server. In this DNS server, I will set up host to IP address mapping. That means if somebody from this computer types google.com or cisco.com, I want it to send, because naturally it doesn't know what cisco.com is, so it has to send a request to the DNS. It'll ask who is cisco.com, and I want this server to tell that cisco.com or whatever domain we'll configure, we want it to tell that this web server 1.192.161.3, this is where that server is. So every time that person types a domain name, the request should go here and it should send the files back. That's the first thing we're going to do. Second thing what we're going to do is we want this to be the DHCP server, and you know, this is a different network, so this is going to be the 2 dot network and this is going to be the 3 dot network. Now I want this computer, right, this computer to also request for a DHCP IP address, but the DHCP server is still going to be this, right? But when this computer requests for a DHCP server, obviously it's a broadcast network, right? If DHCP request, if you remember from our discussion in the DHCP video that we did many videos ago, the DHCP is a broadcast, so the router never sends broadcast. So this the request comes here, and then normally this would drop it, but we want to make sure that this router is a DHCP relay agent. That means whatever DHCP request it comes, it will forward it to this device. This device then will look at that request and give it an IP address. But can it give it an IP address from the 192.168.1.0 range? No, because I need a 3.0 range, because this is 192.168.3.2, right? So I need this computer to get a IP address from the 3.0 range, right? So we need the mechanism to tell that. So this relays and this DHCP server should have multiple pools. Depending on who is requesting, it needs to send that across, right? So we'll look at how it is. So first we'll go here. We will configure the IP addresses as it is in the diagram. So I'm gonna go here and I say no, right? Okay, no, enter, configure terminal, and I'm going to say host name DHCP server, right? This is a DHCP server. Then what do we give? We'll give the IP address interface f0/0. I think this is f0/0. I'm just going to be quick. I'm going to check what is this. f0/0, f0/1, 0.0.0.1. Perfect. Okay. 0.0, we will give the IP address 192.168.1.1 255.255.255.0. no shot. Interface f0/1, IP address 192.168.2.1 255.255.255.0. no shot. Brilliant. Okay, now we have enable these two interfaces. These two interfaces are fine. Now let's go and create an IP pool, right? So IP DHCP pool. Okay, let's do this. IP, right? It's telling IP. Then I say DHCP. I'm going to question mark. It says I can do excluded addresses. This is where we prevent DHCP from assigning certain IP address, like we discussed. We will come back to this. We will say pool, and we can do relay. So let's do pool now. So IP DHCP pool. Then it says word. So let's give some name. Let's say net1. That means it's a first network. And the next possible thing is to hit enter. So hit enter. It goes to a DHCP sub command. What are the possible commands that we have here? We have default router, DNS server, network, exit, no, and option. These are things that is different. So let's start with default router. Let's start with default router. So we say default router, and we want the default router to be this IP address, 192.168.1.1, right? That means whenever this computer gets an IP address, if we want this to be the gateway, right? So default router is 192.168.1.1, right? And we hit enter. Then we're telling this pool is configured for what network? That is network 192.168.1.0. Remember, I'm giving the network ID, and it says give the mask, that is 255.255.255.0, right? And hit enter. And what else? DNS server. So we said DNS server. What is the DNS server? We want this to be the DNS server, 192.168.1.2 DNS server, and we give the IP address 192.168.1.2. We don't have to give a subnet mask, right? And then we hit enter. So we have configured the DNS server here. We have configured what we have to configure here. Now let's do the DNS server. So we'll go to DNS server. Let's go IP address. We'll give a static IP address 192.168.1.2. Normally DHCP servers, web servers, this is all going to be static IP address, because these are infrastructure network devices, right? And only clients are the ones who would be getting IP addresses from a DHCP server. That's how we normally do, right? So this is one of those infrastructure devices, like it's a server. So I'm going to give static IP address 192.168.1.2, 255.255.255.0. It's okay. Default gateway is 192.168.1.1. My DNS server, it's itself, right? 192.168.1.2. So he is the DNS server for itself, right? So I think we're good here. Similarly, I'm going to go give this information here. So 192.168.1.3, 255.255.255.0, 192.168.1.1. This is the gateway. 192.168.1.2. This is the DNS server for this computer, right? Services, because this is a web server, we are here now. This is a web server, right? So I want to create one web server, so I'm going to say web server HTTP is on. Don't worry, these normally web servers are, I mean, not part of your Cisco curriculum, but just for us to show something, I'm going to do this. So what I've done is I've just put HTML file. And so this is going to act as if there is an HTML file that is there in this. So if there is any request, HTTP request that comes to the server will send out this HTML file back to that computer, right? So I've just said, a networking website, blah blah blah, welcome to networking, blah blah blah. I've done that, right? So already there is a file here. I'm going to go here. I'm going to create from the services. I'm going to say this is a DNS service, so I'm going to create a DNS. So what I've done is, I'm going to remove this, I'm going to show it again. www.nwking.org, right? If somebody comes for nwking.org, I want this to be the IP address 192.168.1.3, right? This has to be you need to convert in nwking.org to 1.3, and I say add. So this is added now. So now this is their part of the network. So now this is how, I mean, if you go into your DNS settings on your host, you can change these settings like CNAMEs, A records, NS records, and things like that, right? So like I said, that's a different training. That's not part of this training, so we are not bothered about that. But just know this is how this is configured on a regular website if you're hosting a website, right? So what I've done is I've set this up where NWKing is converted to 1.3, right? I think we're good here. So let me go to this PC and let's try getting a DHCP, right? Let's get config IP address. Let's do a IP address request on DHCP, and you can see DHCP has assigned this device an IP address 192.168.1.4, 255.255, 192.168.1.1, 192.168.1.2, right? If you see, it has automatically assigned it an IP address 1.3, right? It has checked 1.2 and 1.3 is already there in the network, so it automatically assigned an IP address 1.3. But then there are cases where you would have an IP address conflict, where there would be an IP address that's manually configured somewhere on the network, and the DHCP server does not know that. DHCP server assigns the same IP address to a client. Now in this case, if it had assigned an IP address 1.3 or 1.2, obviously there would be a IP address conflict, right? So this device normally does not know that it is already there. So one way to avoid that confusion is manually you tell the server that this is you need to exclude the IP addresses. So we say IP DHCP excluded address, and then we say 192.168.1.1 to 192.168.1.10, right? So you're telling that don't assign IP addresses from 1.1 to 1.10. I'm going to reserve that 10 IP address for various purposes, like your gateway, web servers, DNS servers, file servers, whatever. I'm going to exclude that, right? Now let's do a new request, DHCP request, and you see that now it has directly assigned an IP address from 11, because I have told them don't assign that IP address from 1.1 till 1.10 to anybody. So this device is now assigning an IP address to this device in that range starting from 1.11, right? That's brilliant. So let's go to this, also do the same thing. I say DHCP, I click on DHCP, it's assigned the next available IP address from its pool 1.12, and we're all happy. So it has already set 1.1 as the gateway, and it's set the DNS server to 1.2. Brilliant. Now this is brilliant, right? Now let's do this. I'm going to go to this computer, right, and I'm going to go to a web server in that computer, and I type www.nwking.org, and I say go, and it has given me the website or the web file from this computer, right? The way this computer got to know that nwking.org is available at this is because it sent a request to the DNS server. DNS server told, if you're looking for nwking.org, that is available at 1.3. So this computer directly requested that information here, and everybody is working fine. Now let me do this. I'm gonna remove access to my DNS server. And this computer, now this computer already has it in the cache. So now if I go back here, right, and I say nwking.org and I hit enter, it should technically have it in the cache. I don't know why it doesn't have. Oh, it was the same thing, right? Yeah. Okay, let's try here. nwking.org. If I hit enter, it will definitely not get, but let me do this. Let me connect this. Okay, and nwking.org. It's still in amber state, so I'm just waiting for that. I mean, technically what happens is, if once you have your information in the cache, right, that file is there in your cache, you don't have to contact the DNS server every time. It will automatically start requesting it from the web server. Right, so if I do this, now it is going there, but I think this is something to do with packet tracer. But technically, if I request this information, it is getting, right? It's getting that file again. It's not failing. But this computer, because it has never gone to that website, it will not know how to go there. So it is going to send that request to the DNS server, but the DNS server is not even there. It's failed now, and it doesn't know where that web server is, and it fails. But this computer will not fail host name unresolved, so this cache is failing, but normally the cache will not. So you understand the gist, how it works. So that's how it works. Now what we need to do now is I want this device also to get an IP address from the pool from this server. So I'm going to go here and I'm going to create a new pool, IP DHCP pool net2, right? And the network is 192.168.3.0.255.255.255.0. DNS server is the same thing. Let me keep the same DNS server, even though it's in a different network. I want that to be the DNS server, 192.168.1.2, right? And what are the information? We need to give a default router. Because it's 3.0, I want this to be the default gateway, right? I can't give this as a default gateway. I mean, if you know anything what we have learned so far, we know that it has to be within that same network. So 3.0 is the network and 3.2 will be the default router or the gateway. So I'm going to say 192.168.3.2 will be the default router, but we need to do this configuration. We have not done the configuration, so I'm going to go here, no, enter, configure terminal, interface F0/0, which I think is this. I have short-term memory. Yeah, it's F0/0, so that's the IP address. So I say IP address 192.168.2.2.255.255.255.0, no shutdown, interface F0/1, IP address 192.168.3.2.255.255.255.0, no shut. I think we are good here. So now if we go here and I say DHCP configuration, this device is going to request a DHCP request to this server, right? I mean, it's at a broadcast and it doesn't actually find a DHCP server because there's no DHCP server, so nobody responds to its request. So what it says okay, there was no DHCP server that was found, so I'm going to put an IP address, or the automatic private IP addresses, whatever that is, APIPA, like we discussed in the last video, and it gives an IP address in that range, 169.254.133.157. so everything is good, it is happening, and we know why it is happening. Now what do we want to do? We want to, whenever this device, right, the gateway device, receives a request for a DHCP server, we want it to pass that, right? We want this to become a relay server. We want it to be a DHCP relay server. Now before we do that, let's do one more thing. We'll enable RIP routing, right? So router RIP version 2 network 192.168.1.0 network 192.168.2.0. Similarly, I'm going to enable router RIP, right? Network 192.168.2.0 and network 192.168.3.0, right? So technically RIP would be enabled in both these devices, so we would be able to communicate. Now we need to go into this interface, right? Interface F0/1, that is this inside interface of this network, and I have to tell it IP helper address, right? Helper address, and we need to give what is helper address. We want if there is any IP DHCP request, the help address for this device is this network IP, I mean this IP address, that device basically. So that device is available at 192.168.2.1, right? Now any request this device gets for a DHCP would be automatically forwarded to the DHCP server, right? So let's try requesting an IP address, and oh, okay, I think we create a pool here. We created a pool there. What did we do? What did we do that we did not? Let me quickly go. We created a pool 192.168.3.2, DNS server 3.0. We give 3.2 here. Network 2. We did this. What did we miss? Okay, I'm gonna quickly, let's troubleshoot. Let's use this as a troubleshooting. So I'm gonna say ping 192.168.2.1. Why is it not pinging? 2.1 is not pinging. That's strange. I have mixed it up somewhere. Let me just quickly check. So what have I done here? Show IP interface brief 1.1 2.1. okay, that's fine. Oh, here, the IP address. Simple things, guys. This is how you fail exams. Okay, anyway, let's not do that mistake you guys, if you're practicing, don't do that mistake. IP address 192.168.2.1. Sorry. Bad day. Making so much simple, silly, rookie mistakes. Anyway, so when we go here, we say DHCP request, and it should technically give an IP address from that 3.0 again. Really again? Now what? Show run. I'm gonna see what we have done. 2.2 is fine, 3.2 is fine. Router rip is fine. Do you have routing protocol? Show IP route. Rip routing 1.0 is there. Rip routing is fine. What else? Why isn't it giving? Where do we give the IP help address? We give the IP help address, right? IP help address 192.168.2.1. 2.2, 3.2, 255.255. We're okay. We seem to be okay, at least. What is going wrong? What is going wrong? Really? What is going wrong? Show run. Exclude address 1.0. Net 1 is 1.0. Net 2 is 3.0. 255.255.255.0. 3.2. 1.2. 255.255.255.255.0. 2.1. Both are in access mode. Rip router version 2. Both of them are in version 2, right? There's also version 2? Is not? Okay, I'm gonna just make this router rip version 2. Show IP route. Oh, it doesn't have a route? Okay, I think that's because there was a mismatch in routing versions that we used, so it should be okay now. This fellow knows the route, but he doesn't know the route, and that is where the problem is. So now he knows the route, so now technically it should work, right? Very simple thing, guys. I'm really sorry, I'm not feeling too well today, and that's the reason I'm making such elementary mistakes. Please forgive me for that today. Anyway, so you can see that it has now assigned an IP address in that range 192.168.3.6 and 192.168.3.2, which is the default gateway, and it has assigned the DNS server as 192.168.1.2. Now technically, now if we do the same thing, we go to that browser and say www.nwking.org. This request should come to its name server. Its name server is nothing but 1.2, and this name server would send information back to that PC2 that if you want networking, you need to go to 1.3, and then it will send a request to 1.3 and get that file. So let's see if it accesses. Yes, it gets the website available at 1.3, and I think we are all good. So that is how you'd make this into a DHCP relay or DHCP using the command help address. We make this into a DHCP relay server, right? So I hope whatever we discussed today made sense to all of you. It's very easy. It's not that complicated. DHCP and DNS is very, very critical if you're getting your computers onto the network, right? So I think you have a lot of fun. And like I said, we are almost reaching to the end of ICND 1, maybe a few more videos, and I think all of you are good for ICND. We will have some practice tests. I will set up the website in the meantime, and I think you can go and write your ICND. So we have few very critical topics like ACLs and NAT. We've not spoken about NAT. We'll do NAT and PAT and few more things, and we are really ready for ICND 1. And a lot of people asking me this question: how come your video was uploaded in 2013 or 2014, and how come you are still valid for the new CCNA? The reason we are valid for the new CCNA is because we have whatever things that we have spoken so far is something that was there in the old CCNA and the new CCNA. So we have not done any topic we don't have in the new CCNA, right? So now, since we're adding more videos, I am not going to add videos that is part of the old CCNA, which is I'm going to make sure that we are putting only topics that's there in the new CCNA. So whatever you've learned so far, it is absolutely valid for the new CCNA, right? So don't worry, just stay tuned. We will record a new video very soon. So stay tuned. I'm going to catch you all in the next video.